Hello everyone. So guys, I'm Rahul Kaushik and I welcome you all on Unacademy's JEE English channel guys. So JEE English, now as you know guys, on this channel we cover each and every topic of IIT JEE in pure English, and today I'm here with a rapid revision course guys. Every one of you know about this rapid revision. We are covering complete 11th and 12th in next 2 to 3 months. Okay guys. So are you ready for it? Yes. Am I audible? Please tell me guys. So now we are going to start because we have already covered 3 lectures of periodic table, and today I will be covering, along with those 3 lectures, I will be teaching you the modern periodic table and its application. Guys, why do we call it modern periodic table? What are its applications, and how can we use that modern periodic table to find out those things which are really required for us, right? Like we will be calculating how many number of elements are possible in a period. Right now we have 7 period, but suppose if in the exam you are asked like in 10th period how many element will be there, so you will be able to answer all those questions guys. And if somebody asks you after writing the configuration of an element, just tell me the group number and period number of this element, so I will teach you guys how to use electronic configuration to find out period number and group number. Okay guys, so these are all things which we are going to cover. And before starting today's class, yes guys, this is rapid revision course. Again, let me tell you guys, through this course we are trying to cover in next 3 months complete 11th and 12th chemistry, and without leaving even a single concept. So don't worry about the concepts guys. So before starting this, yes, let me tell you something about myself guys. I'm Rahul Kaushik. I just a minute. I worked in Bansa classes Kota guys for continuous 10 years. I worked there for continuous 10 years guys. I was head of department there and I mentored 2000 plus IITs guys. So after that I co-founded my own organization, that is Jigyan Education Private Limited, and now I'm here on Unacademy, India's largest and fastest growing online platform. Okay guys, so this is my brief introduction. Now let's start how you can subscribe to Unacademy. That's important point guys, because if you are part of Unacademy, you have subscribed to it, you will be getting many advantages. Like currently on YouTube, we are delivering just video lectures, but when you are preparing yourself for IIT JEE or any other competitive examination, then just video lectures are not sufficient guys. Just video lectures are not sufficient. Along with video lectures, you need to cover the application part. So you need content. Your course should be structured. You should have access to the test series, and guys, believe me, you are going to get all these benefits if you are subscribed to an Academy's Plus program. So how you can subscribe to that? So guys, just go to Play Store or App Store, download an Academy's Learning app. Once you have downloaded it, install it, and after installing it guys, just click on the plus. So once you click on the plus, choose the goal. Suppose you are preparing for IIT JEE, then choose IIT JEE as your goal. Okay. Hi Mahendra. So once you have done it guys, then hit the subscription button, and after hitting the subscription button, guys, then you have to choose a program for 12 month or for 24 month. So guys, here for 12 month, if you are applying this code Rahul Chem, then you will be getting a flat discount of 10%. Let me tell you the fee structure. For 1 year, instead of 38,000, you have to pay 34,000. For 2 year, instead of 56,000, you have to pay 50,000. Got it guys? So these are all the benefits which you will get if you are applying this code Rahul Chem. Rahul, my name, and Chem for chemistry guys, right? So just remember it guys, and after that this will be your fees either for 1 year or 2 year, because if you are going for IIT JEE, then you have to prepare for at least 1 to 2 years. Okay, so now let's start today's class guys. Let's start today's class. Are you ready? Are you ready for it? Okay, So now let's start. So in the previous class, I told you the importance of periodic table or the arrangement. When you are arranging something in proper pattern, then it becomes easy to utilize that. Like I gave you an example of library in which books of various science, fiction, history, geography all have different sections. And you know, if you are looking for a science book, then you will go to the science section. If you are looking for a fiction section, then you will go for there, right? So these are the important things regarding the arrangement which we discussed in the last class. Okay, guys. So today I will be discussing Mendeleev periodic table. We have covered that Mendeleev predicted Eka aluminum, Eka silicon, these things. This was the Mendeleev's original periodic table, and then zero group was added to it. So we modified this table because in initial table it did not have this zero group, because Mendeleev gave original periodic table in 1869 and these gases were discovered in 1885 and later, right guys? So after this, yes, now let's come to the point. So this is the long form of periodic table. And why do we call it long form, guys? Here you have two blocks, we call them S, and after S we have 14 elements of F block, then we have 10 element of D block, and then we have guys P block element. Are you getting it? So there are 6. So if you add them all, what you are going to get? 16 and 10, 26 and 6, 32. So guys, if we keep these 32 elements in a single row, then what would happen, guys? Yes, this periodic table would be bulky, and it would be difficult. It would be difficult, guys, to always maintain this periodic table. And if you are going to draw this table on A4 size, then it would be very small. The text size would be very small, and it would be difficult for analysis purpose, right? So what we do, actually these are F block elements, and most of them are man-made or they are rarely used in day-to-day life, right guys? And many are radioactive. So what we do, we shift F block at the bottom, and what will happen then, this table will move from here to here, and this table will shrink, and after removing 14 element you will left with the 18 columns. Got it? We call them groups. So 18 columns are relatively easier to manage than the 32 columns. Okay guys, so after this guys, the periodic table of element will look like this. Yes, can you see it? It will look like it. Got it? So if this periodic table is looking like it, guys, here we have S block element, here we have P block element, and here we have D block element. So that classification we are going to do now, and these are called F block. So these are lanthanoids, 4F series, and these are actinoids, 5F series. Okay guys, so now you know what is 4F, what is 5F. Getting it, guys? Any doubt? No doubt. So after this guys, let's talk about the classification. These are lanthanoids, these are actinoids, and this is the configuration, right? If you see, if you look at this configuration, guys, it would be 2s1, 3s1, 4s1, 5s1. So these are all S block element, these are all P block element, and these are D block element. So how can we distinguish them? Now I will tell you guys. Yes, if I'm writing, so the configuration will be 2s1, 3s1, 5s1, 7s1. Got it? Now we have We got it? So guys, now you will write 2s2, 3s2, 4s2. So what I want to tell you here, that if last electron is entering into the s orbital, then I will call them s block elements, right? And after s block, suppose this is the periodic table. So when you make the periodic table, guys, yes, you make it like this, and then you have two series over here, right? So this series, yes, so these are, guys, s block, these are s block, these are p block, and these are d block. Okay, so here I can say S block, D block, P block, right, guys? So SPD. Now let me show you, guys. This is S, these are P, and these are D block. These are F block, and we call it 4F, we call it 5F. So 4F series, so D block series, we also call them transition elements. I will discuss that all elements are not transition, right? I will discuss it. So, and these we call it inner transition, inner transition. I hope now you got it. What do you mean by transition element? So D block elements are generally called as transition. And what is inner transition? So F block elements are generally called F block inner transition elements. Got it, guys? So now let's move. If last electron is entering into the, if last electron is entering into what? Can you tell me? If last electron is entering into s orbital, then those will be called s block element. In p orbital, then those will be called p. How? Yes. So guys, here you can see, right? So all these elements are called p block because last electron is entering into the p block, right? Similarly, when you are making the periodic table, here we have 3D. So why do we call d block element? Because last electron 3D1, 3D2, 3D3. So last electron will enter into the d orbital. That's why these are called d block elements. Okay, guys? Any doubt? So now you know that what do you mean by classification in S block, P block, D block, and F block. Got it? So guys, S block elements. Yes, let's have a quick revision over them. In which last electron enters into the s orbital. These are generally present in 1a or 2a. Got it? 1a or 2a or 1 or 2, because now instead of a and b we generally call them 1, 2, 8, 9, 10, 11, 12, 13, right? You know that in books it is also written as 1a, 2a, 3a, 4a, and here we call them b. Getting it? Here we call them b, right? So instead of a and b, now I will directly call them 1 to 18, right? You can see here 3, 4, 5, 6, 7, 8. So there are 18 groups, and in the new periodic table you have 7 periods. So these are called periods, right? And position of hydrogen is not fixed. We are placing the hydrogen at the center because it has similar properties with this and halogens. So it is difficult whether we should place it. So it is placed there. Got it? So once we have placed it there, guys, so S block element 1A or 1, 2A or 2. And what is their general configuration, guys? So general configuration will be NS1 to 2. Either it will be having NS1 or it will be having NS2 configuration, right? So what is P block? So I just told you that these are P block. So p block can have configuration ns1, sorry, ns2, np126, right? Because p can have maximum. So like you can have 2p1, 2p2, 2p3, 2p4. So it can have any value between 1 to 6. So this is the general configuration of 2p1, sorry, p block element, right? So this is the general configuration for p block. Got it? So now let's talk about the d block. Now let's talk about the d block, guys. So what is d block? So if we are talking about the d block, let's discuss it. These are d block element. यारी जरा निभा मौत तक. First of all, let me complete it. First of all, let me complete it and its configuration, guys. So it will be 4s2, 3d1, 3d2, 3d3, and then you have exceptional 3d7. Sorry, it will be 3d5. It will be 3d5, 3d6, 3d7, 3d8, 9. So again, exception. Here we are having 3d10. So what I want to tell you here, guys, that it is ns2 nd1 to 10, but at many places the configuration is 1 here. At many places configuration is 1. So ns2 would be wrong, right? ns2 would be wrong. Yes, hydrogen is s block element. We call it s block, but in periodic table we put it in the middle. Okay, Mahendra, you are right. So what I'm saying here, guys, if I write here instead of nickel, if I'm writing here PD, PT, so the configuration for PD will be, yes, 4d10, 5s0, 5d10, 9. So what I want to tell you here, guys, yes, you have to remember it. For nickel, PD and PT. So this is also a D block element, but in S, 0, it is having 0 electrons. In S, it is having 0 electron. And if it is having 0 electron, what would happen, guys? What would happen? Now I will tell you. If it is having 0 electrons over here, so the configuration, general configuration, what I have to write here, guys, it would be ns 0 to 2 and n minus 1 d 1 to 10. Got it? So this will be the general configuration for D block, because you can have options like it A, B, C and D. They will say so your answer will be this, because S can have 0 as well. Because S can have 0 as well. Got it? Any doubt? So now let's move, guys. So the D block element. So D block element, last electron enters into the D. So here, if I ask you that valence electron, tell me how many valence electron will be there. So guys, I will say 2 valence electron are there, and last electron is entering into the D. So D electrons are not called valence electron. So what are valence electron? The electron present in the orbital having value of n maximum. 4 is the maximum, 3d is not the maximum. the outermost shell. The electrons present in the outermost shell are called valence shell electrons. Got it? So guys, this series is called 3D, 4D, 5D, and we call them transition series or d block element series. Got it? So when we are talking about the transition series, guys, so these are the series. Now remember it, 57 to 72. So where are the 14 elements? Those are F block element. We place them at the bottom. So the general configuration here would be NS 0 to 2. Okay guys, so now let's move D block. The first transition series, 3D series, contain 10 elements. It starts from scandium and ends at zinc. Scandium to zinc. Second transition series start from yttrium and end at cadmium. Third, lanthanum to mercury. So their configuration you can remember: 3D10, 4D10, 5D10. Now I will discuss, guys, what are transition elements. What are transition elements? So D block element and transition elements are different. Now I will tell you that all these are D block. Why? Because their last electron is entering into the d orbital. So they are all d block elements. Now if I'm talking about the transition elements, so what are transition elements? So transition elements have incomplete d orbital. Transition elements should have incomplete d orbital in neutral state or in most common oxidation state. Right guys? So when I'm talking about the zinc, cadmium and mercury, when I'm talking about them, so zinc is having 3D10, 4D10, 5D10. So guys, we have here completely filled d orbitals, and if their d orbitals are completely filled, guys, then what would I say? That these are d block, because their last electron is entering into the d orbital. That's why I'm calling them d block element, but these are not transition elements. Right guys, these are not transition elements. So now you might ask a question like, sir, if I take copper, its configuration is 4s1 3d10. So why do we call it a transition element? Why do we call it? Because it is having completely D. It should not be a transition element. So in case of copper, its most common oxidation state is +2, and the configuration in +2 would be 3d9. So here it is incomplete. So it should be incomplete either in neutral state or in most common oxidation state. Got it? So guys, these are transition elements. So zinc, cadmium and mercury are not transition elements. So we have 4 D transition series, guys. Now for F block element, yes, for F block, guys, I will write n-2. So if we write 6s2 5d10. So if I'm writing it as n, I'm writing it as n-1d. So it will be n-2f. Are you getting it? So here I'm writing ns2, and then -1d can have 0 to 2. If you look at the configuration, yes, this is the configuration. You can find it in NCRT, right? If you can't see it clearly, then you can go and watch in NCRT. So once you are going to see this, the NF will be 0 to 14. Just remember it, guys. So D can have 0 to 2. D can have number of electrons 0 to 2. Got it? So now they are also called inner transition element as they contain 3 outermost shell. Why they are inner? Because this is the outermost. Then then it comes the 5D. So these are called transition and they are below 5D. So we will call them inner transition elements. Got it, guys? We will call them inner transition elements. So the elements after uranium, neptunium, plutonium, americium are called trans-uranium elements. So the elements after uranium are called trans-uranium elements. Okay, guys. So the actinoids and the lanthanoids have been placed at the bottom of periodic table to avoid the undue expansion of periodic table. Got it? So now you know about the transition advantages of long form we have already covered. So guys, now what are the main advantages and how can we use this periodic table? How can we use this periodic table, guys? Now we will discuss it and we will discuss it in detail. Okay. So electronic configuration is used in determination of period of an element. What does it? Can you tell me? So electronic configuration is used. So what will be the period? Suppose I'm giving you 1s2, 2s2, 2p6, 3p3. I don't know this is the configuration for which element this configuration is there. But if I ask you, can you tell me the period of that element? So guys, just by looking at the configuration, yes, you can tell about the period just by looking at the configuration. So guys, in this periodic table, if you look at it, we have maximum value of n is 3, so its period will be 3, right? So period number, the maximum value of n appearing in electronic configuration will be its period number, right? So period will be 3. Similarly, if I give you something like it, yes, can you tell me the period number? Be fast, guys. Hello, Papi, ready? Tell me the period number. Write in the chat box. Write in the chat box, guys. Write in the chat box. Be fast. 4. Yes. Why? So now you know, guys, the period number will be equal to the maximum value of n appearing in the electronic configuration. So guys, electronic configuration is used in determining of period of an element. So now you know how to find the period of an element, right? So guys, can you tell me the period number for, we have nickel, we have PD, PT. So for PD the configuration is, tell me the period for PD. Be fast. I'm waiting for your answer. Not PT, I'm asking for PD. What will be the period number? Tell me, guys. What will be the period number? Got it? Okay, now I will tell you guys. In this case, the configuration for nickel is 4s2 3d8, 5s0 3d10, 6s1, 5d9. So guys, you have to remember them, right? So in this case, this is 0. So I'm just writing 4d10 here. This was wrong, 4d10. So the maximum n is 5, 4, but its period number will be 5. Its period number will be 6. 6s1 is there, right? You can even look at it in periodic table. So guys, I told you that remember this thing. I told you that remember this thing. Okay guys? Got it? So now here you can see this is the PD. So again, this is 5th, PT, this is 6th, this is 4. So I think now it's clear. So for memory purpose, I'm telling you these are the exceptional configurations: chromium, copper, and then remember it. Because except these three, I don't think anything else will be asked in your exam. Okay guys? So now let's move. Electronic configuration can be used to find out group number. And you have to number the groups like 1, 2, 3, 4, 5, 6 up to 18. So how will you do it? How will you do it? So suppose I'm writing it will be 2s1, 4s1, 7s1. Got it? So in general I'm writing ns1. So it is 1. So I will call it 1a or group number 1. If I'm writing it for BE, so what it would be guys? 2s2, 3s2, so it will be ns2. It will be ns2 guys. So its period number is 2. Its period number is 1. So what I want to say here guys, the number of electron in s orbital. So if an element is s block element, the number of electrons present in s orbital will be its group number. Only for s I'm telling you. Coordination we will take it during the 11th, or I will arrange some lectures for that definitely. So guys, here you can write group number will be equal to number of electrons in the last s, right? So in general, tell me the group number and period number. Yes guys, be fast. Tell me the answers. Be fast guys. Yes, I'm waiting. So for this group number, because this is S block element, so this is only for S block element. So group number will be equal to number of electron in the last S. So we have 1, so group number will be 1, and N is 3, period is 3. In this is 2 and this is 4. So maximum N is 4, so the period number will be 4. Yes. Yes, Nehanshu. Got it? Any doubt? Is that done now? So guys, now for next, for P block. What is for P block here? So for P block, let me show you the P blocks. Yes, these are the P blocks. So group number, if I'm writing 1, 2, so this is 13, this is 14, this is 15, right? And if I write the configuration here, it would be 2p1 or np1, and it would be 2s2. So it is 2s to 2p1 for boron I'm talking about. So we have 3 electrons, but between S block, between P block, we have 10 elements of D block. So when we are numbering them, so I have to add these 10. And then 10 plus 2 and 1, 3. So guys, in this case, what we will do, group number will be equal to 10 plus valence shell electron, means Ns and Np, because their N is maximum. I'm talking about valence shell electrons only. Got it? So when I'm talking about valence shell, you will have this. So the group number will be 10 plus valence shell. This is the rule for P block. Suppose I'm writing, tell me the group number and period number. Be fast guys, I'm waiting. Be fast. Tell me the group number and period number for both. Tell me guys. Be fast. Any answers? Yes, Nehanshu. So for this, so for the first one, yes, what will be the group number? It will be 10 plus 5, 15. And what will be the period guys? N is 2. Period is 2. Got it? And what is the group number for it? Tell me what is the group number for it? For this one. So guys, we have NS and NP. 7, 17. So you always have to take the valence electrons. Valence means the N will be maximum for them. So Nehanshu, it is not 7, it would be 17. 10 plus valence electron, NS and NP. And what is the period for it? 4. What is the period for it? It's 4 guys. Got it? So now let's talk about for D block. So if I talk about the periodic table, guys, these are the D blocks, and this is 1, this is 2, we have here 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So these are D block elements here. So if I'm writing, suppose you know the position of scandium, this is scandium, so its period number is 3. Why I want to tell you the scandium? So when you are writing 4s2 3d1, so how will you calculate? How will you calculate the period number and group number? So period, you know that period number will be, tell me the rule. Don't read the rule whatever is written on the screen. Just tell me your own rule. Just make some rule, guys. Make some rule here. Be fast. Tell me. So guys, in this case, period will be 4th and group, you know, its group is 3rd. Group is 3rd. So group is 3rd, and how can we calculate that group? Number of electron in Ns and N minus 1d. Just do this calculation. Why you are counting Ns? Because there are 2 electrons of S. There are 2 electrons of S. Those are always filled before the D block. So you always have to do this, right? Similarly, I can give you any, we can take one more example here. Tell me the group number and period number. Tell me, guys, the group number and period number. Be fast. Yes, Nehanshu. Yes. Tell me fast. So in this case, N is 5. So the maximum value of N is 5. And 8 and 2. Group number will be 10. Got it? Group number will be 10, guys. Any doubt, please ask. Please ask. Yes. So now you know the rule. The number of electron in Ns and N minus 1d. Just add them. You should also know why we are adding them. Okay. If we talk about the F block, first of all, you should remember that 4F and 5F. So 4F start from 58 to 71 and 5F from 90 to 103. It starts from thorium and it ends at lawrencium. And for this, it starts from cerium and ends at lutetium. So most of the students don't remember it. They think that lanthanides will start with lanthanum. No, they start with cerium. Okay. So they start with the cerium, guys. They start with the thorium. Always remember it. And their period will be 4th. So it will be 6th period. It will be 7th period. But their group will be always fixed. Lanthanides belong to the 6th period. Actinides belong to the 7th period. But their group is always fixed. Again, I am telling you guys here. Here we have lanthanides. And here we have actinides. So are you getting it now? So actinides are present on the 7th period. Lanthanides are present in the 6th period. And now for increment in atomic number by 1, its group number increases by 1. But in case of F, all these elements belong to their period number. Their period number is 6th and 7th. But guys, their group number, their group number is always 3. For all 28, their group will be always, because we have removed them from here, right? We have shrunk this table at here at this point, so their group number will always be 3. No, you don't have to remember the configuration of F block, right, Nehansu? You don't have to remember that. You just have ideas, whatever I have told you on the board. You just have to remember only those things. Just remember only those things. Okay. So now let's move. We can find out the possible number of element in a given period. How we can find that out? Can you tell me now? So guys, if you have observed it, now let me tell you, for every period, it starts with 2s and it ends with 2p, 3p. So and so on. So what I want to tell you guys, that for every period starts with ns and ends with np. Why I'm telling you this? Just note it down. Every period starts with ns and ends with np, right? So just leave the first period, except first period. So if I'm talking about the second period, so it will start with the 2s and with the 2p. So 2 and 6, 8 electrons are possible. So there will be 8 elements. So in second period, you can see, in second period 1, 2, 3, 4, 5, 6, 7, 8, we have 8 elements, right? And third period, we have again 8 elements. Now I will again do it for the third period. Yes, how will you do this? You will write 3s2, 3p6, again 8 elements. What about the fourth period, guys? What about the fourth period? Just calculate the number of possible electrons in the fourth period, because that will be equal to the number of elements. Tell me now, what will be that value, guys? So it will start with the 4s and end with the 4p. In between 4s and 4p, we can have, because if I calculate, here n plus l, right? So it will be, guys, n plus l, it will be 4 and it will be 5. In between 4 and 5, we can have one more orbital, that is 3d. And if you calculate n plus l for it, it will be 3 plus 2, that is 5. So how many electron you can fill into it? How many electron you can fill, guys? 2, 10, 6. So there are 18 elements. Got it now? Now can you do it? Can you do it for Oh, it's not erasing because I have saved it. Not an issue. We can do one thing. Yes. Can you do it for fifth period, guys? Sixth period, seventh period, be fast. And then for eighth period, and then for ninth period, do it. For fifth period, you will start with the 5S and end with the 5P. Then you can write here 4D. So it will be again 18 elements. So guys, your fifth period will have 18 elements. Now do it for sixth. Do it for sixth. And tell me the answer. Be fast. So what will you do here? 6S2. So here I can write 5D and 4F. What I'm doing, guys, exactly I'm reducing it by 1 and increasing it. If n plus l, if I write 6 plus 0, 6 plus 1. Now what I'm doing, 5 plus 2, 4 plus 3. Now if I write 3G, actually 3G is not possible. So we have 10 electron and we have 14 electron. So in sixth period we have 32 elements. In sixth period, guys, we have 32 elements. Yes, Nehanshu, you are right. What about the second period here? Seventh period here? Tell me. So for the seventh period, let me take it here. Seventh period, it will start with the 7S and it will end with the 7P. Now I will write 6D, 5F, FG, 4G. Is it possible, guys? So let me check. L 6 S P D F G H I. So here what I can do, that 4G, N is 4 and for G L is 4, so this is not possible at all. And if it is not possible, guys, so I will write 2 electron, 6, 10 and 14. So again in the seventh period you will have 32 elements. Note it down. In the seventh period you have 32 elements. Now can you do it for the eighth period? Yes. Can you do it for the eighth period, guys? Be fast. Just do it. So eighth period, we will start with the 8S. Tell me. Now I will write 7D, 6F, DFG, 5G. So 5G is possible because for G, L is 4, so it is possible. And if I write 4H, this is not possible, 4H. So it will be 10, 14 and 18. So how many elements will be there, guys? 50 elements. Got it? Yes. So do it for ninth period. Do it for ninth period. Be fast. Be fast, guys. For ninth period, you can do it. And tell me the answer. Do it. So you will start with the 9s, end with the 9p. Here you will write 8d, 7f, 6g, 5h. So 5h is not possible because L is 5. So again it will be 50. Now what about the 10th period, guys, here? Suppose in your periodic table you are having 10 electrons. So how will you do this? We can't say anything because 200 years back no scientist thought that there would be 118 elements. They knew only about 20 elements. Then after 40-50 years they knew only about 60 elements. So now we have double. So we can have anything. So we can't say nothing is impossible. Everything is possible. So just solve it now. Now tell me the answer. In this way you can do if you are asked in the paper that how many maximum elements can a period have. So now you can calculate that. There are 7 periods and we have done the calculation till 10th. So I'm not getting any answers till this point. 10s, 10p. Then I will write 9d, 8f, 7g, 6h. So 6h is possible. So how many elements will be there? 72. Yes, Nehanshu, you are right. 72 elements will be possible there. Okay, tell me now. Any doubt? So now let's move, guys. What is the importance of this periodic table which I have told you? The number of elements. So let me make the periodic table here. Okay, let me make it again. Right. So we have 3D, 4D, 5D and 6D. Okay guys, so why I'm telling you? Okay guys, and at the top then we have this is the first period, second, fourth. Guys, now listen me carefully, because why do we were calculating number of element in the period, right? So now you know that in second period you had 8, 8, and here you have 18, 18, 32, 32. And what were the number of period if there would have been 18th element? There would have been 8th period. And how many elements were there in the 8th period? You just calculated it. Tell me guys in the chat box. So in 8th period you had, tell me guys. Okay, now I will discuss it, but before that let me take it. So we have helium here, neon, argon, krypton, xenon, radon. Got it? So why I'm telling you this guys? So for helium we have atomic number of 2. Now add 8 electrons, we have 10. Now add these 8 electrons, we have 18 here. Now add 18, so we will have 36. And now add 30, 18, so 54, 86, because I have to add these 32. So you have to add those elements which are present in that periodic table, right guys? So can you tell me now, yes, if some element is discovered here, if some element is discovered, now it is discovered, so can you tell me the atomic number of that element? Can you tell me the atomic number of that element? Yes guys. So in 7th period, how many element are there? 32. So you can just say, sir, it would be 180. Just add 32, right? Similarly, if tomorrow we get another element, y, in 8th period, so can you tell me what will be the atomic number of that element? So guys, in 8th period we have 50 elements. You counted it. So it will be, just add 50, it will be 168. So guys, using this periodic table, you can even predict the atomic number of future element and about their properties. Like this X and Y will have similar properties, like we have helium, neon, argon, krypton, xenon, like these only. Yes, Neha, so you got it. So always remember it. Always remember it. Now suppose if I ask you to find, so this is we have, now can you write the configuration of PO using this periodic table? Now I will teach you how to write the configuration of elements. Even if I'm not giving you the atomic number, still you can do that. Just try to yourself, then I will tell you. For PO, do it guys. Do it, be fast. Tell me guys, any doubt? So now I will tell you that without knowing the atomic number of PO, how can you write the configuration? So for PO, what can we do? Before PO, just look at it, xenon 54, and this is the fifth period. Now PO belong to sixth period, so I will write xenon and it will be 54, and then I will write 6s2, and after here you should also remember scandium and La. After here we have F block element, F block. So what I will do here, 4f14, and then I will write 5d10, and then I will write 1 2 3 4. Yes, 6p4, because it will start with 6f and end with 6p. So without even telling you the atomic number, I told you how to write that configuration. Okay guys. Similarly, let me take one more example here. If I ask you to write configuration of antimony, so can you write it for SB antimony? So how will you write it? This was for PO and now for antimony. Just write guys, just write. That's why I call it modern or scientific periodic table. Using this periodic table, I can write configuration of anything without knowing its atomic number even. Now tell me guys. Be fast. So guys, this SB belongs to fifth period, and before that we have krypton. So I will write krypton 36, and then I will start with 5s2, 5s2, then 4d10, and after 4d then we have 5p3. So this is the way guys how you can write configuration of each and every element. Now suppose if I ask you that write the electronic configuration for an element having atomic number 53, how will you write it? Atomic number 53, how will you write it? Be fast. Tell me now. Be fast guys. So now you have to remember all these. If you don't remember it, it would be difficult. So 54, just below 54 you will be having 53, and it belongs to fifth period. So how will I write it? Krypton 36. Then because it belongs to fifth period, 5s2, and after 5s2 I will write 4d10, and after 4d10 I will write 5p5. So guys, without even knowing the element, I wrote its configuration. So I'm again telling you guys, just remember it, and everything you can do. Just remember it, and how many number of electrons are present in a given period. If you remember that, then you can solve any problem. You can do anything then. Okay guys, tell me now. So just note it down, this is very important, whatever we have done on this page. Yes, that was the crux of yesterday's and today's, means the previous and today's lecture, means almost 3 lectures crux it was. Okay guys, so now let's move. We can find out the possible number of element in a period. Now you know how to find that out. So just do it guys. This is the problem from NCERT. Do it. Be fast. Do it. So for Z20, you will write argon 18, and after this, just remember it. Helium, 2, 10, 86. So argon 18, and after that 4s2. 20 electrons are filled. So now period will be 4 and group will be 3. Sorry, group will be 2. Got it? S block. Yes, Nehanshu, you are right. Got it? So always remember it and you will never face an issue. You can write any configuration of any element. Okay, guys? So now let's move to the next problem, guys. Z120 and Z117. Be fast. Again, this is a problem from NCERT. Tell me guys, be fast. Tell me, tell me. Again, you have to use that periodic. Yes, whatever I have told you, you have to use that. So just write helium, right? So this is the first period, second period, third, fourth, fifth, sixth. So in seventh period, you know that there would be 32 elements. So the next element will be 118, right? So it is asking for 117 and 120. So 117 will be here only. So its group number will be 17 and period number will be 7. and 120 will move to the next. So after this 120 will be here 119 and then 120. So its group number will be 2 and period will be 8th. I hope guys now this is done. I hope now this is done guys. Are you done with it? So now let's move guys. Question number 1. Do it. Match column 1 with column 2 and select the correct answer. So in column 1 this shows 52. So write that. So 52. It will be just before that. So here we will be having 53 and here we will be having 52. So 16th period. And again this will be a P block element. So 52 will be a P block. And what about 56? So after 54 it will move to 55 and 6 S block element. So 56 will be S block. So just check 1 with Q and 2 with P. 1 with the Q, 2 with P. So these two can be the answers. These are rejected. Now you have to check for it. It is 57 guys. So where is the 57 guys? Where is the 57? So guys you have 57 after it the third element. So 2 for S and third will be for D. So guys it will be a D block element. 57 will be the R. So guys D will be your answer. Got it? So your answer will be D. Now you should know guys, yes, this problem was asked in September 2020 mains. Yes. How will you do this? Nomenclature of elements having atomic number more than 100. How will you do that nomenclature? So 1, 1, 0. For 1 we use un, nil plus em. So guys from NCRT you can use that. Yes, even in the previous class we did how to do the nomenclature for elements having atomic number greater than 100. So it would be unnillium. Unnillium. So B will be the answer. Got it guys? So now let's move to the next point. Do this one. Z98. Z98. From which block it will belong guys? Be fast. No answers? So guys I'm telling you that we have 4F. We have 5F. It starts from cerium to lutetium, thorium to lawrencium. So just remember their atomic numbers. It will be 71. Got it? So I'm saying 98. It means it will be in between them. So it is 5F. So it is not S block, it is not transition element, it is inner transition. So D will be your answer. Got it? So I told you guys, remember these things. Otherwise, you would not be able to answer these questions. Otherwise, you would not be able. Right? So now let's move, guys. 47. In the same group means you are moving down the atomic number of element placed above and below in periodic table will be. This is fourth period, this is fifth period, this is sixth period. You know that this is containing 18 element. Containing 18 element. So if you are moving up, 47 minus 18. 47 minus 18. So it would be 29. And if you are moving down, the sixth period will have 32 element. So what will you get? Just add 32. So it will be 79. So guys, your answer would be C. So again, this problem can be solved if you know, guys, how many number of electrons or how many number of elements are there in a particular period. Got it? Now let's do this. Tell me now, which of the following is correctly matched? Sorry, not correctly matched. Be fast. Be fast, guys. Got it? So guys, for P block, you know that general configuration will be NS2 NP126. Now it says 1 to 2. So this will be incorrectly matched. This will be incorrectly matched. Okay guys. So these are all the problems. The general configuration of this. And if N is 7, so just put it here. It will be 5F. So it would be lanthanoids or actinoids. Actinoids. If it would have been 4F, then it would have been lanthanoids. Got it, guys? So identify which of the following is the ground state configuration of argon. So 4S to 4P1. So it would be GA. So if you know the periodic table well, then you can answer all these questions, guys. Now let's take the next one. Not a bridge element. Yes, I'm just helping you to revise the concept we have covered in the last class. So guys, argon. I told you that in argon, it does not make any bridge. Got it? So let's move. Which of the following does not belong to P block? Do it, guys. Be fast. Tell me now. So here I am telling you configuration of helium is 1s2, although it is placed with the P block, but it is S block. So C will be the answer. So helium is not a P block element. It is written in the NCERT, and I personally think that this problem will be asked in IIT JEE Mains or Advanced. And that's a very good problem. So the next problem, select the configuration of neutral atoms which belongs to S block. Sorry guys. So you can easily do that. This one. So guys, now this is done. Now this is done guys. So in the next class we will be starting screening effect. What do you mean by screening effect? How you can utilize it? What are its applications? And after that we will be studying the Slater rule, but we will not go into the details guys. And after doing Slater's rule guys, I will go through an inert pair effect. So what is inert pair effect? What are consequences of inert pair effect? Okay guys. So after doing this magnetic moment, radius, we are going to cover all these topics in the next class. Okay guys. So we are covering the periodic table in a faster way. Now guys, this is all for today, and I would ask you to like it and share it. If you really like today's class guys, then please share it and like it, and then click on the bell icon so that you can get latest notification of our lectures. Now again, you can subscribe to Unacademy. Just download and install our app, and then click on the plus, then choose your goal as IIT JEE, and then hit the subscription button. Once you are hitting the subscription button guys, then you can apply my code Rahul can. If you are applying this code, then instead of 38,000 you have to pay 34, and instead of 56,000 you have to pay 50,000. Okay guys, so this will be the fee structure which you have to follow guys. And again, thank you everyone. Thank you everyone for being part of this fantastic class. And again, I will meet you tomorrow 2:30 p.m. with chemical bonding. Tomorrow we will be doing hybridization. Thank you guys. Take care of you. Bye bye.